we have been writing up our code by using um, C language. Earlier, we have just been developed applications using C language, and C basically comes under procedural programming language. We basically came from procedural programming language. Okay, so basically, procedural programming language was available in the 70s, and we built up all our applications by using those procedural programming languages. And unfortunately, the drawback with the procedural programming languages is procedural programming languages doesn't provide security and reusability. Procedural programming languages doesn't provide security and reusability. Security and reusability are the biggest problems what we come across in procedural programming languages. They don't provide you. So that's why to overcome this particular problem, in the 80s, in the late 70s or in the early 80s, in the late 70s or the early 80s, object-oriented programming came into picture. Object-oriented programming. So the procedural programming was replaced by a new approach called as object-oriented programming, providing you security as well as reusability. So up to 70s, we worked with the procedural programming. In late 70s or in the early 80s, procedural programming was replaced with a new concept called as object-oriented programming, providing you security and reusability. So like this, object-oriented programming languages are born. Fine. From that point of time, means from the early 80s till now, 80s, 90s, till these 40 years, all these 40 years, industry was building applications by using this object-oriented programming approach only. Since the 40 years, industry was building its applications by using object-oriented programming approach only. Yeah, we are using object-oriented programming approach only for building the applications still. I'm sorry, guys. Since the last 40 years. Now, there are so many object-oriented programming languages in the market. There are so many object-oriented programming languages in the market. C++ language, Python language, Java language, C# language, VB language. All these are object-oriented programming languages. So many languages are there, not like one or two. There are 40, 50 languages which are in the market, which are object-oriented. But here we get a doubt. What the doubt is? Sir, when can we call a language as object-oriented? The doubt that comes into picture is, when can we call a language as object-oriented? So this will be one of the biggest doubt in our minds. When can we call a language as object-oriented? Okay. Let me clarify. When can we call a language as object-oriented means? If at all you want to call a language as object-oriented, if at all you wanted to call any language as object-oriented, basically the language to be called as object-oriented, if at all you want to call any language as object-oriented, the language needs to satisfy 4 important principles, guys. If you want to call any language as object-oriented, the language needs to satisfy 4 important principles. Any language that is going to satisfy these particular 4 important principles is actually going to be called as an object-oriented language. Any language which is going to satisfy these 4 important principles, we call this as an object-oriented language. Yes, Any language, if it satisfies these particular four principles, we call that language as an object-oriented language. What are the four principles? What are the four principles that a language has to satisfy to be called as object-oriented? I repeat, guys. Any language to be called as object-oriented needs to satisfy the four important principles. A language that satisfies all the four principles is actually going to be called as an object-oriented language. So what are the four principles a language should satisfy to become object-oriented? I repeat, what are the four principles a language should satisfy to become object-oriented? The four principles are called as encapsulation, abstraction, inheritance, and polymorphism. Encapsulation, abstraction, inheritance, and polymorphism. Any language, if it satisfies these particular four principles like encapsulation, abstraction, inheritance, and polymorphism, we call that language as object-oriented language. Are you clear, guys? Any language which satisfies four principles that are prescribed by the language. What are the four? Encapsulation, abstraction, inheritance, and polymorphism are called as object-oriented languages. Did you understand this point first? So what I'll explain you. But did you understand? To call a language as object-oriented, you're required to satisfy the four principles: encapsulation, abstraction, inheritance, and polymorphism. Okay. So all these four principles, if satisfied, that language can be called as an object-oriented language. So you'll be wondering now, sir, what is this encapsulation? What is the abstraction? What is inheritance? What is polymorphism? Okay, I'll tell you them in a simple way, simple words, guys. See, you guys may not be having any knowledge on object-oriented programming prior. You guys may not be having any knowledge of object-oriented programming prior. You might not be learning C++, you might not be learning Java, you might not be learning any of these languages. But I'll tell you one thing. Each and everyone in the classroom, each and everyone sitting in the classroom, each and everyone sitting in the classroom, everyone sitting in the classroom is aware of the four. You might say, sir, I did not learn C++. No need. No need, guys. No need to learn C++. No need to learn Java. No need to learn object-oriented programming. But all of you know the four. These four things, you really apply them in your day-to-day life. We use these particular four principles in our day-to-day life. Every day we use them in our day-to-day life. We apply them in our day-to-day life. We use them, we apply them in our day-to-day life. We don't know that this is called encapsulation, this is called abstraction, this is called inheritance, this is called polymorphism. But all the four, we use them every day in our day-to-day life. Okay, let me clarify. First thing is encapsulation. What is encapsulation? Guys, remember, after cooking the food in the home, how do you protect the food? Come on, answer me, please. After cooking the food in the home, how do you protect the food? We just put this inside some container and we put a bowl or a lid on it, and a bowl and a lid. Yeah. Preserving. We cover. Cover. Okay. How are you protecting yourself from the virus now? How are you protecting yourself from the virus now? A mask, you're wearing a mask, sanitizer, but you're forgetting a very important thing. By staying at home. By staying at home. Yeah, you're staying at home. You're staying at home and protecting yourself first. The first thing is stay home. Don't go out until and unless necessary. Staying at home is the one thing how we are protecting ourselves. Am I right? So, a simple common sense all of we are applying here. What is it? By staying at home, surrounded by the four walls, we are just getting an assurance like virus doesn't enter into the home and it is not going to affect us, right? Exactly. That is only what we call as encapsulation. That is only what we call as encapsulation, wrapping. See, you go out. When you go out, you're wrapping your face with a mask. You're wrapping, you're wrapping your face with a mask. Your nose, your mouth, all these things you're covering with a mask. And this mask is a wrapper. This mask is a wrapper which protects you, right? So encapsulation is nothing but wrapping. All of us know about wrapping here. All of us know about wrapping. We do wrapping every day in our life, everything. To protect the food, we wrap it in a container. To protect our clothes, we wrap them in a wardrobe. We wrap them in a wardrobe. To protect ourselves, we are wrapping inside the house, inside the four walls of the house. So a wrapper is always going to protect the content that is present inside. A wrapper is always going to protect the content that is present inside. And the same principle was applied here also. The same principle was applied for you here also. What is the principle? The principle that has been applied for you is, uh, yeah, all these are wrappers. So the same principle what we are applying here also. What is it? We are protecting the members of a program. We are protecting the members of a program by wrapping them under a container, what we call it as a class. Tell me, are you not writing the code inside a class? The day when you started programming, you have written all the code inside of a class only, right? Yes or not? So we are always writing the whole code inside of a class. And that class is going to be the wrapper which is protecting us. And in procedural languages like C, did you write the code in a class? Did you write the code in a class in a C language, guys? No. And but when you come to object-oriented programming, you're writing the code inside of a class, and that class is going to give you all the protection. Come on, read this and watch the picture. Read it and watch the picture. Now tell me, are you using encapsulation in your day-to-day life or not? Are you using encapsulation in your day-to-day life or not? In every part of our life, we have encapsulation, guys. Here also we are using the same encapsulation. The same principle only we are applying here also. We are protecting the members inside of this particular class. Okay, now? Fine. Next. What are the next thing? See, encapsulation is basically hiding the code, hiding the data. Where are you hiding the data? Encapsulation means hiding the data. Where are you hiding the data? Class. Perfect, Amit. Class. You're hiding the data inside a class. You're hiding the data inside a class. And that class is going to protect you, all the members. Okay, now? Next. Next. The next thing is abstraction. What is abstraction? Abstraction means, guys, abstraction means hiding the complexity. Abstraction means hiding the complexity. What is it, hiding the complexity? Correctly understanding that hiding the complexity means, see, you might be driving a car. You might be driving a car. Okay? But tell me, As a driver of the car, is it important to know how the engine functions? As a driver of the car, is it important to know how the engine functions? No need. No need. But see, the car runs with an engine, and the engine is going to be a collection of hundreds of functionalities inside. And if all these functionalities work perfectly, then only the car moves. If all the functionalities of an engine are going to run perfectly, then only the car moves. Am I right? Yeah, if all these particular functionalities are well managed, then only the car moves. So if these things are not well managed, the car doesn't move. So all of us know this, the car moves with this. But as a driver of the car, it is not at all important for us to understand. As a driver of the car, it is not at all important for us to understand how it's not at all important for us to understand how exactly the engine functions. We don't require to. We don't require to know how the engine functions at all. Then what we really require to know? What we really require to know? What we really require to know is only how to control the engine. Am I right or not? What we require to know is only how to control the engine. That's all. How to control the engine, guys? To control the engine, it will provide you a set of interfaces to you. To control the engine, you are provided with a set of interfaces to you, like what? The clutch, the brake, the gear. Yeah, the clutch, the brake, the gear, the accelerator, all this. By using all these things, can you control the engine or not? That is only what we call as abstraction. Abstraction, see, hiding the complexity. Yeah, what is that hiding the complexity? The underlying complexity behind the functionality of the engine, the underlying complexity behind the functioning of the engine is hidden from me, is completely hidden from me. But what is it doing? It is exposing me a set of interfaces like the clutch, the brake, the gear, and all. And using that, I'm able to drive the car. And using that, operating them, I'm able to drive the car. So that is what we basically call as abstraction, hiding of the complexity. That's what we call as abstraction, what comes into picture. So you may have a doubt here. How this is useful for us in our application development, sir? How do we use this? Abstraction is present in procedural languages also, guys. Abstraction is present in procedural languages also. Procedural languages also has abstraction. The best example for the abstraction is functions. All of you called a printf function in C language, no? All of you called a printf function to print something in the C language. Okay. Okay, but can you answer this question? When you call printf, what happens behind the screen? Don't say printf will print the output on the monitor. We know that. But what is my question is, when we call printf, what happens exactly behind the screen? Do you know that? That's what I'm telling you. It will print the output. That's what we know. But what I'm asking is, behind the screen, what will happen? We don't know behind the screen what is going to happen. Behind the screen, what will happen, it is going to send a request to the operating system. It is going to send a request to the operating system asking for the handle to the computer's monitor. It will send a request to the operating system asking for the handle to the computer's monitor. Once it gets the handle to the computer's monitor, it will identify the X and Y coordinates of the screen. It will identify the X and Y coordinates of the screen and prints the output on the monitor. and it is going to print your output on the not going to print also, it is going to paint the output on the monitor. So this is the underlying logic. This is the underlying logic. But what exactly do we know really? What exactly do we know really? We exactly know how to call a printf. Printf, percentile yes or something, comma, hello world, what you want to print. That's all. And it is going to print you the output. Are you getting me? See, the logic behind the execution of the code, we don't know. The logic behind the execution of the code, we don't know, guys. We only know calling it and printing the output. But how exactly the logic is going to execute behind the screen means we don't know. See, we called a sort method, remember? We called a sort method earlier, remember? To sort the values of an array. But if the question arises there, the sort method is using which algorithm to sort? The sort method is using which algorithm to sort? It is using a bubble sort or a quick sort or which type of sorting has been, which algorithm has been used? Do we know that? We don't know. What we know, how to call the sort method. How to call the sort method array.sort and pass the array to it. Once we call array.sort and pass the array to it, it's going to sort you the values of the array. That's it. Are you guys clear? So that's what abstraction is. That's what abstraction is all about. We don't know the underlying logic at all. What we know, how to call them and executes to you. See, abstraction, you find abstraction in every part of your life. You have abstraction in every part of your life. See, you have a watch. You have watch. Do you know how to see the time? You have a watch. Do you know how to see the time? Do you know how the watch functions? You have a mobile phone. Do you know how to make a call? But if I ask you a question, how the radio signals are transmitted from your mobile to the target mobile when you make a call. If I ask you a question, do you know how the radio signals are transmitted from one machine to another machine or one mobile to another mobile when you make a call? We don't know. What we know, guys? Red button, green button. Red button to cut the call, green button to answer the call. That's called abstraction. So in every inch of your life, in every inch of your life, you will be having abstraction involved. In every inch of your life, you'll be having abstraction involved, guys. Okay? Third one, inheritance. Guys, do you have money in your pockets? Do you have money in your pockets? In your wallets and all, do you have money with you? I don't want your money. I don't want your money. Your money or not? How did you get it? How many of you are doing a job and earning? What about the rest of the people? All the people who are having money in the pocket, are you doing a job? Yeah, the parents are giving you. The parents, yeah, you're getting from the parents. Why the parents are giving you? Why the parents are giving you? Because that is law. That is law. What law? All the property of the parents belongs to the children. All the property of the parents belongs to their children. Yes, whatever our parents are earning, all that particular property belongs to us. They give that particular property to us. And that is the law of inheritance. Hmm. That is the law of inheritance. That's the law. What else? And the responsibility of the children should be taken care by the parents. The responsibility of the children taken care by the parents. Guys, that's what. Okay. So your father purchased a car. A father purchased a car. He was driving the car. In the future, the father, can you drive your father's car as if you're the owner of the car? Your father purchased the car. Yeah. Right now, he was not using the car. He was just got aged and not using the car. Can you drive your father's car as if you're the owner of the car? Yeah, I can. Basically, my father's car means my car only. Right or not? My father's car means my car only. No one can object me on this. It's my father's car. It's my father's car means my car. I can drive my father's car as if I'm the owner of the car. I can drive my father's car as if I am the owner of the car. Am I right, guys? Okay. So that's what inheritance is all about. So simply speaking, inheritance will give you reusability, guys. Inheritance will give you reusability. It will provide you reusability. Till now, your parents are using it, and now you start using it. They'll give you reusability to you. Okay, so that is going to give you reusability for you in this. Till now, your parents have been using it, and from now, you can start using the things here, and that's going to be giving you the reusability. So inheritance gives you what? Reusability. Okay. So now, how I can use this in my application development? Can you ask me? How can I use this in the application development, sir? Um, how can we use it in application development means? Assume it like this, guys. Till now, just assume it like this. What? Every class, every class is a collection of members. Every class is going to be a collection of members. uh, the members that are defined in one class, the members that are defined in one class can be consumed from another class now. The members that are defined in one class can be consumed from another class once there is a parent-child relationship between the classes. What I mean? What's the picture? Can you understand the picture? I have a class with